All right. So, what makes a linear equation? What makes a linear equation?
It doesn't have like bends or loops or anything. It's just a straight line.
It's a straight line. It's a line. Exactly. It's a straight line. It either has to go up, all right, from left to right, or it goes down, but it can't be vertical. All right? Verticals are called undefined lines, and so that is not a linear. This is your most known one, a slope-intercept form of an equation. This was your best friend back in Algebra 1. Y equals mx plus b, where m is your slope and b is your y-intercept. It's a y-intercept. Graphs. So we're going to sketch these graphs. We got y equals 2x plus 1. Well, how do I start sketching that little graph? We first start out with the what? The y-intercept. So our y-intercept is 1. It's technically 0, 1 as our y-intercept. And then we use our slope. So our slope is 2. So I just go up 2, right? And then over 1. And in America, we read left to right. So we go up 2 over 1. If I were to go backwards, I'd go down 2 and left 1. And then we connect them with a line with arrows. Why do we do arrows? Because it never stops. It keeps on going. It's like the Energizer. Then we get y equals 2. What kind of line is y equals 2? Vertical or horizontal? Horizontal. It's horizontal. All right? And all we care about is y equals 2. X's can be anything. They have lots of x's on y equals something. All right? What if I get like x equals -4? Something like that. What kind of line would that be?
Undefined.
That would be undefined slope. True that. All right? But all I would care about is x's are the same. All right? So all my x's would be -4. Y's would be everything. It'd be infinite. All right? This next one, I have x plus y equals 2. What form is that one in? That's in standard form. That's in ax plus by equals c form. Most of the time, I like to keep it in standard form. It's actually easier. So then you actually solve by using the intercepts of it. So this is how you do it. You kind of cover up y, and so then you get x equals 2. And that would be the x-intercept. All right, so that's how you could actually graph that. And then you should cover up the x, and then we end up getting what? Y equals 2. And so then you have it up there. And then you can connect the little dots. Now, the wise man says there's many ways to Tampa. You guys right now are probably most comfortable with solving for y. So if you solve for y, how would you do it?
Move the x.
Move the x, which means we subtract it. So we subtract x from both sides. So you'd end up with y equals -x plus 2, right? So you'd start out at the y-intercept of 2, and then you'd use your slope of -1. So you'd go down 1, over 1, down 1, over 1. Do you see how it's the same thing? All right? So the wise man said there's many ways to get to Tampa. All right, here's slope. Okay, we're still in Algebra 1. Slope is y2 minus y1 over x2 minus x1. It's the change of the y values over the change of the x values. However, you have to be consistent with it. And what I mean by that is if you're going to choose this one first, on the denominator, you have to choose that one first. All right? You can't choose like this one first and then that one. Okay? You have to be consistent with it. It doesn't really matter which one you choose first, though. So this first one, I have the ordered pairs of -2, 0 and 3, 1. And I want to find the slope of it. So I would pick what? How do I find my slope? 1 minus 0 over 3 minus a -2. And so my slope would be 1 over 5. All right. Let's do part B. On part B, I'd find my slope by saying y2 minus y1. So what do I have up top? I have what? 2 minus 2 over 2 minus a negative 1. So I end up with what? 0 over 3. So what's my slope there? It's 0. Now, I want to know the equation of that line. What is the equation of that line? If I have a 0 slope, is it an x equals or a y equals? It's a y equals. And what does y equal here? What does y equal? 2. So the equation of that line is y equals 2. Y equals something is a horizontal slope. It's a 0 slope. All right? And the x's can be anything. All right? It's got lots of x's. It got around. All right? Help me out, Max. Part C. What do we got?
-5 over 1.
Help me out. How do I do it?
-1 minus 4.
Good. Over.
And 1 minus 0.
Good. So what do we get?
-5.
-5. Oh, or -5 over 1 is
Oh, -5.
-5. All right. Beautiful. Beautiful. All right. Call on somebody. Pick somebody.
Braden.
Braden, help me out.
You do 1 minus 4 over 3 minus 3.
Good. So what do we get?
You get -3 over 0.
All right. So what's that?
0.
No.
3.
No. Nope. If you divide by 0, if it's a number over 0, it's actually undefined slope. It's undefined. It'd actually be a vertical line. And if it's a vertical line, it's what, Elijah? It's x equals 3 here. All right, it's x equals 3 because the y's change, but the x's stay the same. So it's x equals 3. All right. All right, so this is point slope form of a line. And I'm actually going to change up what that point slope form of a line is because next year, once you get to calculus and then you go further in mathematics, this is actually the most used form of a line. And I think this is silly the way some textbooks write it. I don't ever do y minus y1. I actually put y1 on the other side. So I'm going to say y equals y1 plus the slope m times x minus x1. That's actually the way upper level mathematics will write most forms of a line. And I'm going to say something and you'll figure it out in a few years. That's actually a first degree Taylor polynomial. And that's actually why we actually write it like that. It actually makes a lot more sense this way, and hopefully you can trust me. All right, so here we go. So I'm going to write the slope-intercept form, which is what? Y equals mx plus b. So the comfortable form, your comfortable form, with an equation of a line that has a slope of 3, so that's your m, and then a point, 1, -2. So it's a point and a slope. So I'm going to use point slope form because that's what they gave me. And so I end up having y equals, well, what's my y1? -2. So now I have -2 plus my slope of 3 times the quantity x minus 1. All right? Now, that would be a perfect thing if it just said, give me an equation of a line. And most of the time in calculus, we leave it like that. We don't have to go further. Very rarely do we actually have to go to slope-intercept form. But it tells us to, so we're going to do it. So, what do we get to do to this 3? We're going to distribute this. All right? So then I have -2 plus 3x, and then -3. And then I have one last step. We do what? We combine like terms, so I end up having y equals 3x minus 5. And then I'm good. All right? These two are the same values of them. All right? If you want to see the line, hey, there it is. All right? Perpendicular lines. All right? Parallel lines have so much in common, but they'll never meet. So sad. All right? Parallel lines will have the same slope, different y-intercepts. All right? Perpendicular lines will have opposite or negative reciprocals of each other. All right. They'll have slopes that are negative reciprocals or opposite reciprocals, if you want to call it that way. Volunteering, go for it. The problem.
Find the slope-intercept form of the lines that pass through point 2, -1 and are A parallel and 2 and B perpendicular to the line 2x minus 3y.
All right, fantastic. So I need parallel and perpendicular with this point. All right, I need parallel and perpendicular with that point. So what do I need to get from this line? This 2x minus 3y equals 5. What do I need to extract? I need to extract the slope. So let's do it. So how are we going to do it? We kind of need to solve for y a little bit. How do we do it? Do what? I need to get y by itself. So I need to subtract 2x, right? And I really don't care about this 5, honestly. And then I need to divide by what? I need to divide by -3. All right? So then I get y equals, what's -2 divided by -3? Positive 2/3 x. And then I technically have -5/3. But I honestly don't care about the -5/3. Why? Why do I not care about it? Because I don't need it. What do I need? I just need the slope. I honestly just care about the slope. All right? And so what is the slope here? 2/3. All right? I get 2/3. So if it's parallel, do I want 2/3? Yes, I want the same slope. So now let's make a line. So now I have y equals, what's my slope? 2/3. And then x minus, what's my x value? 2. And then minus 1, or plus -1. However, they're kind of harsh, and they make you say, what's the slope-intercept form? If you just had to find a line, you're done. You're done. All right? Most of the time in calculus, we actually leave it just like that. But we're going to go a step further. Let's see how well you do with fractions. So we're going to distribute. So now we end up having y equals 2/3 x. And then minus what? What's 2/3 times -2? -4/3. Now, what do I want to think of this 1 as? I need to add fractions together. I need common denominators. So what do I want to think of 1 as? 3/3. All right. So then I combine like terms now. So now I'm left with y equals 2/3 x minus 7/3. 7/3. All right. And then we're done. Now I'm going to do perpendicular. So that was parallel. Now I'm going to do perpendicular. All right. So what do I need for perpendicular slopes? They are what of each other? They're opposite or negative reciprocals. So instead of 2/3 as my slope, what do I want my slope to be? -3/2. All right. So now I'm ready to make my lines. So now I have y equals -3/2 times the quantity x minus 2 and then minus 1 again. But I'd be done if it just said make a line, but I actually need to make it in slope-intercept form in this case. So what do I get to distribute? The -3/2. So now I end up with y equals -3/2 x, and then plus 3, right? Because it's really a positive 6/2. If you need to go both ways, it's fine. All right, so it'd be plus 3, and then minus 1. All right, and so then we combine like terms. So I get -3/2 x, and then plus 2. What do we need to make a line? We need a slope. Well, let's make a slope then. But first I'm going to make these into ordered pairs. In 2006, it was 35.9. So how could I make that into an ordered pair? All right, we actually want to go the other way. So we get 2006, comma, 35.9. All right. So now we're going to find the slope between that. So I do y2 minus y1 over x2 minus x1. So I get 40 minus 35.9 over 2007 minus 2006. And so what do I get? 4.1. So the slope there is 4.1. So now it just says write a linear equation. So let's do it. So I got my slope. I got one of my points. Which one do you want to use? Doesn't matter to me.
2007
I like that one better too. It's a little less writing, isn't it? All right, so now we get y equals 4.1 times the quantity, x minus what? 2007, and then comma, or not comma, dear goodness, and then plus 40. All right. So I wrote my linear equation. Did it say it needs to be in slope-intercept form this time? No, so I'm going to leave it just like that. I'm going to leave it just like that. So now I can use that to predict in 2010. So I kind of have the equation, or the ordered pair 2010 comma question mark. That's really what I'm trying to find out. And so all I do is I substitute in what? 2010 in for x. So now I have 4.1 times 2010 minus 2007 plus 40. All right? So 2010 minus 2007 is 3. 3 times 4.1 is 12.3. 12.3 plus 40 is 52.3. How much? $billion. All right. There you go. Enjoy. Have fun.